We are going to discuss the concept of Ohm's law. Ohm's law is a relation connecting voltage, resistance, and current, right? So first of all, let's take a look at what is voltage. Okay, to understand voltage, the concept of voltage, let's take a water tank as an example. Here, the water represents the charge. Amount of water is equal to charge, and the pressure, you mean the pressure is dependent on the height of this water column, right? So the pressure applied on this water tank, that means the more the height of the water column, more the pressure. This pressure is equal to voltage in our electrical terms. The amount of water flowing per second, or the flow of water, is more or less equal to the current through the circuit. So we know here the pressure, more the pressure, more will be the flow of water, right, through this hose. So this pressure or voltage is nothing but what, the difference in potential between 2 points, right? Here difference in potential between these two heights. In our electrical world, is a difference in electric potential between 2 points. Okay, and let's discuss about current, the current, the concept of current. Okay, here also let's take an example of a water tank. Here we have two water tanks, with one with a wider, wider, and one with a narrow, right? One with a wider area of cross section, one with a narrow area of cross section, right? The width is wider here, width is narrow here. In the wider, in the no hose with a wider width, the flow of water will be higher. The hose with the narrow width, the flow of water will be less, right? So also, to compensate this, the lesser flow, we can add more pressure, right? By increasing pressure, the flow will be higher. So we just increase the, the height, we just increase the water height of water level. So here pressure will be higher, so water flow will be higher. So what, the amount of the flow of water will be equal at this ends for both of this tank. We just did what, we just did raise the height of the water column. So we can say what, the rate at which the charge is flowing. Here the rate at which water is flowing is affected by some parameters, right? Here pressure, that means water pressure affects the flow of current. Also the area of cross section of this hose also affect the flow of water, right? Though, so this flow of water is nothing but the rate at which water flows. Similarly, the rate at which the charge flowing is called current. So this factor current is also affected by, in here pressure, in electrical word voltage, right? The current is also affected by such quantities. So we also already started to see some similarities, some relation between current and voltage and everything, right? Let's look at resistance. So let's take an example of a water tank here also. And we have, we already discussed this, this have wider uh, area of cross section, this has, narrow area of cross section, right? Here width is higher, so the water flow will be more. Here width is narrow, the water flow will be less, right? So this width is analogous to resistance in electrical terms. That means if there is no opposition or resistance to flow, that means there is less resistance, right? Here, why? Because why there is a less resistance here? Because there is the width of the hose is wider, but here the width of the hose is narrower, right? So here the width of the hose is narrower, so there will be a resistance to the flow. So the resistance increases, flow decreases, right? So this resistance to the flow, in electrical terms, resistance to the flow of current. So Resistance is what? The property of an electrical component to resist the flow of electric current. Its SI unit is ohm. Now let's look at the Ohm's law, because we already seen voltage, current, and resistance. Where we started to see some similarities, right? Resistance increases, flow decreases. So there is a relationship happening. That relationship is formulated by ohms. That's called ohms law. Okay, now let's replace our physical word example with the our real word electric circuit. Here pressure is what? Voltage. Here we have four cells and a resistance and a ammeter which reads the value of current, and voltage which reads the value of electric potential between the 2 points, right? So first of all, what we are doing is we are just connecting only one cell and taking the reading of voltage and current. Then we are connecting two cells, then taking the reading of voltage and current. Similarly, we are doing the experiment and we will get this as the result. When we have only one cell, we have current 0.5, voltage 2, and V by I ratio will be 4. When you have two cells, current increases, right? Current increases because when we have two cells, we have two cells with a 2 volt. So total potential will be 4. We already seen in our example, right? In water tank, when pressure increases, the flow of water increases. So here voltage increases, the current also increases, but the V by I ratio remains constant throughout the experiment. So we can plot this in a graph. Let's see. We will get a straight line. Here the slope will be same at all points. The slope is called V by I, the ratio of voltage and current. So we will get what? V by I is a constant, right? When V increases, I increases. So V proportional to I. This is called Ohm's law. So what Ohm's law says? It's proposed by George Simon Ohm and says the electric current flowing through a metallic wire is directly proportional to the potential difference V across its ends, provided its temperature remains the same. This is called Ohm's law. So that's it. V proportional to Y and V by I is a constant. V equal to I into R. That constant is called a resistance. So we already saw the concept of the voltage, current, and resistance. We saw there is a relationship happening between them, and that relationship is called a Ohm's law. Right. Thank you for watching.